planar set in terms of molecular geometry and electron pair geometry. So again, I already put the Lewis structures here for you. If you want to know how to do that, go back to the other videos. But let's look at this for now. And the first thing that we want to do is look at the number of, when we're determining, guys, electron pair geometry, we want to count the electron sets on here, okay? So here, 1, 2, 3. Even if it's a double bond, even if it's a triple bond, it's counted as one electron set. Got it? So 1, 2, 3. 3 electron clouds or sets means that the electron pair geometry is trigonal planar, which is different than trigonal pyramidal, guys. All right? Go back to the tetrahedral series and see what trigonal pyramidal means, and I'll show you the shape in a second, okay? Now, the molecular geometry, again, for molecular geometry, you have to count your bond pairs and your lone pairs. So this counts as 1, 2, 3. So you got 3 things bonded to the central atom, and then you don't have any lone pairs on the carbon. So when you don't have any lone pairs, your molecular geometry is going to be exactly the same as your electron pair geometry. So this is still trigonal planar. All right. So let me do the structure for it to help you see it. So we're going to make a double bond. And we're going to use these more flexible. Now in the lab, you guys will be using springs to make your double and triple bonds. So here's what we're going to do. Bonds here. Okay. See, here you go. So see how that looks like? Now, do you see why we call it trigonal planar? Can't you see how all these 4 atoms lie in the same exact plane? So I'm going to turn it towards you like this. Can't you see how they're all in the same plane? So if you saw it right down the middle, you know, they all lie flat directly in the plane of the board. Okay? So that's why trigonal planar. Now, guys, what's the best way to orient 3 atoms around the central carbon so that they are as far away from each other as they possibly can, right? And this is kind of like an equilateral triangle, right? Now, what would be the inner angle of an equilateral triangle? So, what would be the inner angle here? So, it'll be 120 degrees right there. Got it? So the bond angle is 120 degrees for trigonal planar, which is again different than trigonal pyramidal, which has a bond angle of 107, okay? So that's that. Now, is this molecule polar or non-polar, right? So we're gonna look. The first question is, does it have polar bonds? Do we have polar bonds? And you'll learn to do this and realize that oxygen is like right next to fluorine. So chances are it's very, very polar, relatively speaking, more polar than carbon. So the electron density is going to be pushed towards oxygen. So oxygen is going to be partially negative, right? And carbon is going to be partially positive, right? So guys, now to make it easier on yourself, look at the central atom, look at the 3 things around it. Are they the same? If they're not, and you have polar bonds, this is going to be polar molecule. Polar bonds, polar or molecule. Okay? Because these 3 guys are different than each other. So it looks like the electron cloud is going to be pushed more towards the oxygen here. So this is going to look more negative, and this is going to be more cold blue because it's pushing towards the electron density. Okay? So red hot up here, cold blue down here as the electron density is being distorted towards the more electronegative atom. Okay? Now, let's do SO2, sulfur dioxide. So I wrote the Lewis structure up here for you, and I'm going to ask you, before looking at the model, let must count how many electron sets we have around the central atom. So this counts for 1, the double bond counts as 1, and then we have a lone pair here. So we have 3 electron sets, which automatically, from your chart, means that you are trigonal planar. That's your electron pair geometry. Your molecular geometry is different. This is going to take into account how many bond pairs and how many lone pairs are there. So we have 1 here, and then, so in other words, how many, when you're talking about bond pairs, which ones are bonded to other atoms? And here you can see 1 bond here and 1 bond here. So 2 bond pairs. How many other things is my central atom attached to, right? How many other atoms, particularly? That's 2. And then how many lone pairs? This is a lone pair, it's not attached to anything else. So 1 lone pair. So this combination of 2 bond pairs, 1 lone pair, tells you your molecular geometry, which is going to be bent. Because can't you see how this looks bent right here, right? So that's bent, right? But is it the same bend as we did for the tetrahedral series? No, right? Because the bend that we did for the tetrahedral series was made up of 2 bond pairs and 2 lone pairs. This has got 2 bond pairs and 1 lone pair. So, in terms of the bond angle here, guys, the bond angle between these is going to be less than 120 degrees, okay? So here, it was 120 degrees. Here, it's going to be less than 120 degrees, okay? So different books will tell you different things, but for our lab manual, it says just write less than 120 degrees, okay? So again, make sure you take into account that lone pair on this molecule. See that? And again, molecular geometry tells you how are my 3 atoms bonded in this molecule, right? See how it looks bent, right? So you can see that? Okay. That sums it up. We don't have much. We only have 2 possible case scenarios in which we have electron pair geometry of trigonal planar.